So problem set 5, okay? So here we go. I'm just gonna put up the formula answers for problem set 5. And then again, as I mentioned, if you have a question you wanna go over one. So number 1 should be calcium oxide, CaO. Number 2 should be barium sulfate. And again, if you have the oxygen and the sulfur mixed up, that's okay for right now. I just expect that at this point you can put the metal first, followed by the non-metals. Okay? And I'm not going to judge you on the order at this point. You could, but you don't need to in this case. Right? If there was a subscript for like, if this is not right, so don't write this down. If it was like a subscript 2 that went with the sulfate, yes. But there isn't. I think there is another one like this that we'll come across here in a minute. 3 is aluminum chloride. Again, the metal first, followed by the non-metal. Metal, non-metal, okay? Metal, non-metals, metal, non-metal, okay? 4 is, okay. Be careful how you write this, right? Because we're dealing with cobalt. And that's got to be a lowercase o, okay? So some people get lazy and they'll go CO. Okay, that's very different than C little o, right? Yeah, so be careful with cobalt. Okay, cobalt sulfide. Metal first, followed by the non-metal. Yes. Yes. So this one here, let's take a timeout for a second. This one here, you probably will get moles that are not whole numbers, right? So, for instance, I think you get, if I look at this right, you get a 1.3, right? Or 1.5. Oh yeah, 1.5. It would be something like that. And so, because 1.5 is not a whole number, you must multiply it by another number to get you a whole number. Does that make sense what I'm trying to say? Okay. So if we need to go over this after, we can. But essentially, you should have gotten, I think, for, let's see, cobalt, no, sulfur, you got, what, 0. 0.01401 moles. That's for sulfur. And then I think for cobalt, you were supposed to get 0.00934, right? And so when you divide the 0.001401, you divide this by the same, you get 1. And here you get 1.5, right? Oh. Yeah. Scratch. Gosh dang it. Yeah, hey, I didn't do the picture. Okay, that gives me 1. That gives me 1.5.
Something like that.
Something like that.
I was so confused with the right.
Okay, now we multiply this by 2. So 1.5 times 2 is what? 3. And this also has to be multiplied by 2 then, because you got to keep the ratio, and that would be 2. Does that make sense? So I know I skipped part of it, and it just went directly to the mole part, which hopefully convert mass to moles. I divided by the smallest number of moles. Here's that ratio, but it's not a whole number ratio. I can't have 1.5 in my ratio. Can't have half of an atom, right? I can't just like split the atom in half. So kind of the rule of thumb is that if it's a 1.01 or 1.0, or if it's a 1.99 or 1.98, that's close enough to a whole number. But if it's not that, then it's not good enough. Really, even 1.8 is pushing it. Okay, you might get away with it depending on the situation, but it's close. Usually we want it in the 9s, the next digit, or 0 type of thing. Okay. But definitely that is not going to cut. Does that make sense, everyone, on that? So yeah, that helps. I will make one clarification though. Your lab report for AP lab number 2, the silver oxide one. When you're in this situation, don't multiply it by an integer. Just go ahead and round it to the next digit up. Okay, I'm telling you that because your lab is good, but it's not like fantastically great at being able to get all the right numbers right. So instead of doing this, just take the numbers you have and round it to a whole number. It'll get you probably closer to the real answer. Okay. Only do it for that situation, that lab. That's it, period. Any other situation, including tests, do not do it that way. Multiply it by a whole number to a whole number. Yes? That was a lot. All right. Where are we at? 5? Okay. 5. Where are you? 5. Okay. Now, this one is the way it really should look. However, you might have written it a little different for you. All right, so it should be copper nitrate. However, some of you might have gone like CuN2O6 or CuO6N2. You want to write it that way? One of those ways? Yeah. Okay. So for now, I'm okay with this. Okay. We'll eventually get you to that.
Okay, so if we did do like the CuN2O6, like how would you know that it needs to be like?
Well, one is because you can take N2O6, all right, and you can reduce this down, right? You can pull out what? You can pull out a 2 out of this, right? So that would go down to N3O2, okay? So you can do it that way, all right? However, you still need to be cautious with that. So, because, yeah, for right now, you can do it that way. This is actually a solid.
Well, I mean, like that I mentioned, that also there's lots of copper, metal, that how you do it?
No.
Okay.
Nope. Not in this case. All right. 6. Let's see here. 6. We have C6H12. 7. Ooh, 7 is a weird one. I'm going to find 7 weird. C6H24O6. Interesting one. We had 8. So the empirical formula is C2H2O, yeah, O-N, or NO. NO would probably be better writing it like that. It's more traditional. Okay, and then the molecular is C6H6N3O3. Good. Okay. And we're at 9, right? 9, I think, is the last one. All right. Number 9. C6H6O2. All right. Take your best picture. All right, take your picture before I erase it. Do we have any questions we want to specifically go by? Yes. Very carefully.
Big numbers.
Did you get some big numbers?
Yeah.
Okay.
You have like C8 and O, and then mine have like C26, H26, M13, O13. It's always like if I'm wrong.
All right. Yeah.
Oh wait, I got the empirical.
You got the empirical?
Yeah.
Well, all you have to do is take that empirical and find the molar mass for it.
Okay, so then the empirical molecular. There you go.
Okay, so you understand how to do it at this point?
Yeah.
Okay. All right, can I erase it? All right, I think we got perfect pictures right now. All right, do we need to go over any of them? Go ahead. Yeah, you're gonna have to do some of that, but essentially just take the molar mass of the compound, right? And take the individual molar masses of each of the elements and multiply it by its coefficients or whatever, right? So like CO2, let's take a look at CO2. So the molar mass of CO2 is like 44.02 grams per mole. Okay, so there's the molar mass. So the molar mass of carbon is 12.01 grams per mole, divided by the total 44.02 grams per mole, and then multiply by 100. Okay, and then for oxygen, since there's 2 of them, you're going to take your 16 grams per mole, and you're going to multiply it by 2. And divide that by, again, the total mass times 100.
Yeah.
And that's it.
I'm going to be tested on that. Is that going to be also on the 18%? Like how much percent? Like what percent do you think that this unit will be on the?
On this, so this one is a little harder to tell you, and the reason why is because this is kind of this unit so like last unit and this unit, the skills are not necessarily like tested in a single problem. It's more of you have to take this, what you do this stuff, and apply it to a much bigger scenario situation. And that's what you're tested on. So you're tested on, like, in maybe one problem, 5 or 6 different principles, with this being a minor principle of the overall big problem. So it's kind of hard right now with the basic principles. I can tell you, like in next unit, I can tell you more of a breakdown. Okay, this unit is hard because it's going to be all over. Okay, it's going to be throughout most of the problems you're dealing with. Okay. There is a lot of stoichiometry on the AP exam at times. So, although it used to be much greater than it is now. They've toned it down just a little bit. Put a lot more other things on there. All right. Anything else? Lesson 5 or problem set 5? Okay. Fantastic. We'll end there then. So if you do have questions,